Okay, this video is over Chapter 13 of your textbook. The title of Chapter 13 is GUI Programming. I'm sure that all of you know that GUI, sometimes pronounced GUI, stands for Graphical User Interface. So years and years ago, decades ago, you interacted with a computer through a command line interface, and you will be doing that to write and test some of your, if not all of your programming assignments. But GUIs are very common these days, and these are some of the topics that we're going to talk about. We're going to talk about graphical user interfaces in general. Like I just said, you probably already know about those. We're going to talk about a module that is named TK-Enter is how you pronounce that. Some people say Kinkter or Twinkter or something like that, but it's based on a library called TK. So they say that the correct way to pronounce it is TK-Enter. We'll talk about labels and putting text on labels. We'll talk about frames. We'll talk about widgets, buttons, dialog boxes, which are all components of a graphical user interface. We'll talk about displaying information on some of these widgets. We'll talk about reading information from the user. We'll talk about radio buttons, check buttons, list box, again, very common components of a graphical user interface. And then we'll talk about drawing pictures. I mean, we've done a little with turtle graphics earlier in the textbook, but we'll talk about how you can draw things on a TK-Enter canvas widget is what they call that. So a graphical user interface is how in current days we interact with a computer. There are windows and buttons to click on, and you know, multiple windows at a time, that type of thing. As I was saying earlier, compared to a command line interface where you're logged in, you know, with SSH to a Unix machine, or you've opened up the command prompt on a Windows machine to run PowerShell or issue commands. Those are all command line interfaces. So they don't have the graphical elements or components that a graphical user interface does. So two things I mentioned here. On the left we have a window on a Windows operating system machine running the command prompt. And then you can issue commands like they're issuing the dir command to do a directory listing of the current directory. And on the right we kind of have the equivalent for a Linux or Unix machine, which is we're in a shell and we're using the ls command, which stands for list, which is a way to list out the files in the current directory. So those are doing the same type of thing, both in a command line interface. When we have graphical user interfaces, one of the real common components is a dialog box. It is a window that allows you to interact with the operating system. Here it looks like we're looking at the security level for the internet properties on a Windows machine. In a text-based environments, we have programs or commands that figure out how things happen. You type in a command and then the computer interprets that command and does whatever you ask it to do. In a graphical user interface, they are considered event-driven, which means the user does things like clicks on buttons or drags things in order, or does selections, that type of thing. So, and when you click on one of those graphical user interface elements, then something happens as a result of that. By default, there is no graphical user interface components built into Python. We use a module called tk-enter, as I mentioned before, and this allows you to create, it says simple GUI programs. You could use this in production and it would be probably an okay interface. And then the term widgets implies things that we can see that are part of the graphical user interface that allows you to view, enter, or interact somehow with the program behind the graphical user interface that is running. So we mentioned a bunch of these. These are widgets that you have available to you. I won't read each of these to you, but most of them are fairly straightforward. A couple things we didn't mention was a true text box for doing text input. I don't think we mentioned a scale widget or a scroll bar widget, but those are things that are available to you in the module. Now, one thing here is there are some things that don't run great in idle, and sometimes there's extra things you have to do. For example, if you're entering an if statement, when you hit return on the last statement, idle doesn't really know that's the last line of the statement, so you have to hit an additional return so it knows there's not another line that has the same indentation as the last line you typed before it'll actually acknowledge that that is a complete command and execute it. Graphical libraries, Turtle Graphics might work okay, but tk-enter really works better if you write a program, put the contents in the file, and then run that program. And part of that is because there's an event loop that needs to be running the whole time to control your interaction with the widgets and the program behind the graphical user interface. So this is object-oriented programming. Most graphical user interfaces, like if you program for Mac OS, it has an event loop, and all the things on the screen, all the components, all the variables are objects. So whether you're using Objective-C or Swift in a Mac OS environment, it uses the object-oriented paradigm. The same is true for the tk-enter module. So when it calls its init method when you instantiate an instance of tk-enter, and that is what, in addition to initializing any variables it needs, it actually initializes, creates, and displays the graphical user interface screen. So here's an example program. They wrote a class, my GUI, and it makes an instance of the tk-enter tk object. Like I said, this was based on a graphical user interface language called TK that came with part of a language called TCL, which is often pronounced tickle. So you have something tickle TK that is the graphics component. So that's where the name TK came from. Once you instantiate that object, you're telling itself to set the name of the window to my first GUI, and then it calls the main loop, which is the event loop. And you will see that when you actually create an instance of your object, that it creates a window and the title is indeed my first GUI. So you haven't put any buttons or text or anything on the window other than the window name. But that's a super simple example of using tk-enter. We display text with label widgets. Here's an example. You call the label module of tk-enter. you pass it the main window, and then you say, I would like the text to be, in this case, MySpace text. So that first object is referred to as the root widget, which is the main all-encompassing window of your GUI. There is a pack method that determines where a widget should be presented. Positioned, which I guess is really presented on the screen. So each widget in the window you need to call the pack object for, and you can tell it basically where to place it, the top, the left, the right, etc. So here we have the window, and we just call pack, which basically doesn't specify where we want it to appear. So it looks like it makes the window just as large as it needs to be to display our text, and then it centers the text within that window. So, there's our first Hello World program, if you will, in tk-enter. Here you are putting two labels. So it considers each label or each line of text or each text argument you pass to it to be a single line. Again, it's just making the window large enough to display your information, and at least horizontally is centering that information. Here we're telling it left and left on the pack. So what it's going to do is it's going to position it to the left, and then position the next one left justified right after the first argument. So if you really wanted those two pieces of text to be on the same line, that's one way you could do that. Possibly better way would be just to use string concatenation and then place that new concatenated string in your window. You can create borders around your label, and then you can also change the border style with the relief argument. So here our text is Hello World. We want a border around it, or a box with a width of 1 pixel, and we want the style to be a solid line. So that's showing you how to use some of those arguments and showing you what the resulting widget would look like on the screen. Here, the same command, I believe. The only exception is instead of 1 pixel border, we have specified a 4 pixel border. So that's what that would look like. This is just showing you some of the things you can do. You can have a solid border, or you can have something that looks like a ridge or a groove, or kind of a sunken 3D appearance, either down or coming out at you. And if we say flat, then there is no border being displayed, which is the default behavior. Okay, this screen is showing the different effects that we discussed on the table on the screen before. So like I said, flat was no border and is the default, and there's examples of raised, sunken, ridge, solid, which we've already seen, and groove. So that's just showing you what your different labels would look like on the screen. Here we're talking about padding, which is extra space around objects. Internal padding is inside the edge of the widget, and external padding would specify space outside of the widget. So they're showing you an example of internal padding and external padding in that graphic. In the case of internal padding, you're specifying the number of the number of pixels in either the X or Y position so that you can get your label placed where you would like it. So here's an example of our Hello World. This is a GUI program again, but for the two label calls, they've added borders, they've specified the width and style of the border, and then you see the effect of that in the top right with them showing the TK window. And it looks like they did not specify a title this time like they did before, so you'll notice that the default label for the window is TK. In the case of external padding, the widget is placed and then it makes sure there is the specified number of extra pixels or padding either in the X direction or the Y direction, depending, or both, depending on what you specify. So here is the program again with two labels, solid border, both of them of width 1. This time they're spaced out a little because we're specifying the padding down towards the end of the program right before the main event loop. This one has both internal and external padding, so it's showing you an example of that and what the effect of that would be. Now, a lot of times what you do is you have a group of widgets that are related and you kind of want to control the spacing and the content together, and we can do that by creating a frame. And then once we have a frame, we can add widgets to it. Here you'll notice that there's something called top frame, and we're basically adding high to it. So here we have an example of a top frame and a bottom frame, and then each of them have 3 labels in them. The first one are on individual lines, the second one are put end to end with a space to them. We have buttons that a user can click on and something happens. You have text that can appear on that button so that the user knows what they're supposed to click, like there might be a calculate button that performs some type of calculation. And then you have something called a callback function, and the callback function is what gets called or executed when you click on that. Some programming languages call this an event handler. There was an event. That event was you clicked on a button. So the event handler is the function or method that you are going to call. We can have info dialog boxes. This provides information to the user. It consists of a title, if you would like one on the title bar, and then it gives some type of message within the main part of the dialog box. So this would be a pop-up window with a message, basically. Here's an example of the main window, which has a click me button, and when you click on it, the event handler or the callback function just pops up a window and says thanks for clicking the button. The name of that window is a response, and there is an OK button so that once the user has read the information and is done with the window, they can click that button to dismiss the window. So here they're showing you how to quit a program. So basically you're going to create a button. I assume it's going to say quit. And if you call destroy on the root widget as the callback function, then it is going to close that window, destroy that window, and your program will exit, or the main event loop will exit. And that's usually the last thing in the main program, so then the main program would terminate. An entry widget is a rectangular area in which the user can type text into. Presumably you're going to read that, so when you call the callback function, it's probably going to use the entry widget's get method, which will take all the all the text the user typed in that box and return it to the calling program as a string. So here's an example. Enter the distance in kilometers. Either quit the program or convert that to miles. In this case, they typed in 1,000 in step 1 and then clicked the convert button, and then a dialog box appeared that says 1,000 kilometers is equal to 621.4 miles. And then there's an OK button to quit that window or close that window. When you close that window, you'll go back to the main box in step 1, where you can either convert a number again or you can actually quit the program. You can use labels to display information if you would like. tk-enter has a string var class that is used to contain variable length strings and to display them to the user, and automatically display that to a label widget for you. So here's an example of that. This is the window that is displayed initially, and notice the second string can be changed to include the answer, so that all this happens in a single window. Would be the advantage to taking this approach. Okay, here we're talking about a couple of things that we can have. The first is radio buttons. Radio buttons are little circles that have kind of a common theme, if you will. Down at the bottom it says they're mutually exclusive, which means only one radio button could be chosen at a time. So an example of this might be a window that appears and says, choose what color background would you like? Red, blue, white, black. And then you can choose only one of those because your background can't be multiple solid colors at the same time. So you choose one. If you choose another one, the first one you selected goes away. And then you would be able to retrieve that selections. We have a tk-enter module class, which is called intvar. It is associated with a radio button. All of the radio buttons share that intvar object, and what it's going to do is it's going to assign a unique integer to each radio button, and when you select one, that value is stored in intvar. You can also use this to set up a default radio button by setting that value. For radio buttons, you can have a callback function, and what it's going to do is it's going to execute whatever command you give, and it is going to basically replace the need for you of saying I want a red background. Okay, you just simply select it, and it's going to call the callback method anytime you click one of those radio buttons. Now, check buttons are very similar. They are represented as square boxes, and you are allowed to pick any or all, which means they're not mutually exclusive. So you can have one or more checkbox checks. So a checkbox might be, hey, I'm creating a pizza. Here's a list of 10 different toppings that you can put on your pizza. Check the box next to each topping. And then when you retrieve that information, it's going to retrieve all the ones you have selected so that you can do whatever you need to do with your list of toppings. Another is list box. This displays a list of items and allows the user to select one or more items from the list. So, here maybe you're working for somebody and you're filling out an employment application, and it says, what days are you available to work? Please select the day or days that you are willing to work. So here's an example of how they set up this window. So basically, you as the programmer specify the padding and what your choices are and what the corresponding values are, and then when you start TK Enter's main loop, it's going to display that window for you to choose the dates. Obviously, if this was a real-world example, you would want to tell the user why they're selecting the dates. You can specify a height and a width of the list box as you do that. Also notice that this time, putting the 7 days of the week in there, they accomplish that by creating a list called days, and then for each day inserting it to the end of the list that's going to appear in your list box. So just a slightly different way to go through and add items to your list box. There are different selection modes that you can use. The default mode is browse, and the user can select one item at a time by clicking on it, or you can select adjacent boxes by dragging through them. Multiple, you can go through and select and unselect multiple items in the list, and if you call it with a single option, then you're only going to be able to select or check one item at a time. So that kind of controls the interaction with the user and the selection process. Once the user has selected items, you can actually select no items and it will give you an empty tuple. If a single item is selected, the tuple will only have one element, and if you use extended or multiple, then your tuple is going to have multiple items, and those items will be all the options that were selected in the list box. Once you have the index of a selected item, you can get that from the list box. It accepts an integer index as an argument and returns the item that is located at that particular index within the list box. So another example, you're going through and you're getting an index of an item and then you're displaying it, or for all the indexes you're going through and displaying them if you had a multiple selection in the example down at the bottom. You can have a callback function for a list box, and when the user clicks an item in the list box, it is called immediately. That's one way to do it. So here You provide a parameter to accept the event as an argument, and then what you can do is, in this case, you're getting the current selection, getting what is at that selected item, and then displaying the text selected item and the particular item that the user selected. So there you're retrieving information on what they clicked. This, you actually bind a method or an action or an event to an method. So in this case, if you see the event list box select, then you want to call the current object show item method. Once that executes, or it will execute once the user selects an item in the list box. You can have scroll bars by using the Y view and X view attributes. So here's an example of doing that. We pack our list box, and then we put scroll bars on there, and then we configure the scroll bars and the list bar to work together. You can do the same thing for horizontal scroll bars, and that's what this would look like. So probably the interesting code is the last two comment pieces or sections of code, which adds a horizontal scroll bar and then makes it work together with the list box. You can add both at the same time. So the code's a little longer because you're having to do this twice. But you can look through this, and it shows how to add horizontal and vertical scrollers to the list box. So the next thing we want to talk about is drawing shapes, and we do that with the Canvas widget. So basically the Canvas widget is a rectangular area within your window that allows you to draw 2D shapes. Now, unfortunately, when we look at different things like turtle compared to tk-enter, usually the X and Y coordinates are the same. X is left to right, Y is up and down. But where you start, or what is considered 0, 0, might be on the middle of the screen in the case of Turtle Graphics by default. In the case of the Canvas widget, it's the upper left corner. So you have the the 0, 0 coordinates in the top left of your window. So you have to be familiar with the orientation and the coordinate system when you're using or looking at different graphics modules. So positive X is to the right, positive Y is down. So that is the Y is the opposite, for example, of Turtle Graphics. And then they're showing you the point that is in the middle, the coordinates of that. So to draw shapes, the first thing you have to do is create a canvas. There is a canvas method that you pass the window, the parent window or main window, and then you tell how many pixels you want. So in this case, they want a 200 by 200 canvas. Once you've done that, there are a number of methods that we will discuss to create lines, rectangles, ovals, arcs, polygons, and text. So we have examples, I believe, of all these. The first is drawing a line. So you give the X and Y coordinates of the starting point, then the X and Y coordinates of the ending point. By default, it will draw a solid line. There are options that let you specify the width and whether the line's dashed and that type of thing. So here they drew a line between the corners to basically make a big X on the screen. So notice that we have a 200 pixel window, so the coordinates go from 0 to 199 in both directions. To draw a rectangle, you give the X and Y of the upper left and then the X and Y of the lower right, and then some optional options. Here's an example of doing that. They made the window 200 by 200, but they wanted what looks like approximately 20 or 19, depending on which direction, padding around that rectangle, so they drew the shape smaller than the window. To draw an oval, you give the upper left corner of the bounding rectangle and the bottom right of the bounding rectangle, that is the rectangle that will just include the oval, nothing less, nothing more. And then within that bounding box, it will draw the oval for you. So here's an example of doing that. All circles are ovals, but not all ovals are circles. So the first one, they drew the circle that's in the top left, and in the second one, they drew the oval that is towards the bottom right of this window. Another thing you might want to do is draw an arc. So basically you have a bounding rectangle. So you have an oval kind of area to draw in, and then what you do is you specify the starting angle and how many degrees or the extent you want the arc to be. So that's how they accomplish kind of that pie-shaped image there on the screen, or showing you the different components. So here's an example of where they created, again, a kind of a pie shape on the right. They started out with a bounding box that was square, and then started at 45-degree angles and moved up to 30 degrees counterclockwise from that, and then TK Enter drew the border lines. To draw a polygon, you can go through and give the coordinates of the vertexes. So here it is basically giving you pairs of coordinates, and then it will draw lines. So it shows you the first point, second point, third point. So you specify the points, and then when you call create polygon, it's going to, if you didn't start and stop in the same place, it is going to close the polygon for you. So here's a solid polygon, which it looks like is the default, and you're specifying coordinates, packing the object, and then displaying it on the screen. A lot of times when you're doing drawings, you want to have text on it. So you can give coordinates of the text where you want it to appear, and then you specify what the text is, and then you can have optional arguments. So here they're telling where to start and display the text, "Hello World." So this chapter has been an introduction into the TK Enter module for creating a graphical user interface and drawing images. So the summary here just kind of tells you the high points of what we hit in this chapter.